This is my advice, and this is also I'm telling myself every day. Today is very tough. Tomorrow is more tougher. The day after tomorrow is beautiful, but most people die tomorrow evening. You have to work very hard. Every tough days, every tough situations, problems you meet, that is the training of yourself.
Hi guys, and welcome back. In this video we're going to be testing our first function, and it is this divide function here. Really simple function. All it does is it takes two parameters, dividend and divisor, and divides one by the other. We're going to be doing a little bit more in this function later on, but for now it's just this. I've also added the typing module here to say that the dividend and the divisor are both ints or floats. Let's go over to our test functions file to begin writing our tests. It is important that your file is called test underscore and then the name, because that's what unit test is going to look at in its default configuration. You can change that later on, but we're not going to look at how in this course. The first thing to do here is to import the test case class from unit test, and also of course our divide function. Then we're going to create a class test functions, for example, and is going to inherit from test case. Inside here we can write our first function. Functions should also start with test underscore. For example, test divide result. This test is just going to check that the divide function returns what we would expect a divide function to return with two normal values. So we'll say that the dividend is going to be 15, the divisor is going to be 3, and the expected result is going to be 5.0. These are just variables. They don't have any specific meaning in our tests, even though they have the same names as the function parameters. It's totally irrelevant. You can name these whatever you want. What is important though is that you do self.assert equal divide of the dividend and the divisor, and then the expected result. So what we're doing here is we're passing to this assert equal method two values, divide, or the result of executing the divide function, and our expected result. And it's going to check that they are the same, so that dividing 15 by 3 is equal to 5.0. We have written our first test. Now, if you're using the default configuration, i.e. your file is called test underscore and your tests are called test underscore and then the name, you can right-click test functions using PyCharm and run the tests. If you are using the terminal, we will have instructions on how to run these tests on the terminal in a little info box. So let's press run, and then you see that you get ran one test in 0.002 seconds, and it is okay, no tests failed. Whenever you're writing a test, it's very important that once you've written the test that you're happy with, you play around with it to make sure that it is actually working. So now I'm going to change the expected result to 4.0, and when I press play, this test should fail. And it does, which is good. And it says here the expected result is 5.0. At this point, let me say that in some cases, when you make a division in any programming language, the result may not be exact. So it could be 5.000000001, just because of how the computers do division. And we'll have some links in the resources section of this lecture to explain why that happens. But if the division was not exact, that is okay if you use a slightly different method. So instead of self.assert equal, whenever you're handling division, I always recommend you do self.assert almost equal. And then the last argument after divide and expected result is a delta, which is what the allowed difference between these two values is. That is just in case there is a small inconsistency in the division there, that this will still work. So now that we've done this, let's press play again, and the tests pass. By the way, down here on the bottom left, there is a small icon that says toggle auto test. This is something you can click on PyCharm, and whenever you make a code change, the tests will run automatically. I usually leave it on when I'm writing tests and I have my code, like in an application. For now, we're going to leave it off, but it is there if you want it. It can be helpful. Let's begin writing our second test, which is for a different equivalence class. We're going to talk later on what equivalence classes and boundaries are when you're talking about testing, but essentially you want to start thinking about what different types of values are that your functions can take. For example, this function in this test we've tried with two positive non-zero numbers. I would call this one equivalence class. These two numbers are similar. You could, instead of 15, type 30. Instead of 3, you could type 10. But you would expect the function to work in the same way with 15 or 30 or 300. However, it may work differently if you put in a negative number. And that is what I would call a different equivalence class, a different type of input. So we will write a test for negative division. And here we'll say that the dividend is 15, the divisor is minus 3, and the expected result is minus 5.0. And then we will do exactly the same as before. We will just test that. Calling the divide function with these two arguments will result in this, or it will almost result in that. Pressing play gives us an okay result once again. Finally, we can try a third equivalence class, which is for a zero number. So we will say test divide dividend is 0. We will set the dividend to 0 and the divisor to 5. And then the expected result should be 0. Whenever you divide 0 by anything, it should be 0. And now we're going to say self-assert equal, because I don't expect the output to be 0 point something. So I don't want to do self-assert almost equal. I want to do self-assert equal. Pressing play again, and there we have our 3 tests. You can see that writing tests can be very straightforward when your code is very straightforward. Here we've got a simple function that doesn't do a lot, and we still had to write 3 tests for it, but they are all very simple tests. And in a simple test, which is a test that I like most, you have your inputs and your outputs defined in the test, and then you have a single check or a single assert at the end. There is a benefit to doing tests in this way, which is that it's really clear what the function does. The function should be able to divide, it should be able to handle negative results, and it should be able to handle a dividend of 0 without giving you an error. We will be adding more tests and also other functions in the coming videos, but try always to keep functions or classes, if you're doing that, simple, and your tests simple and straightforward as well. Let's move on to the next video. I'll see you there.
If you get to be 65 or 70 and later, and the people that you want to have love you actually do love you, you're a success. I've never seen anybody that reaches that age. I mean, I'm not talking about somebody that's in extreme poverty or pain or something, but I've never seen anybody that, if they have a lot of people that love them, that is other than happy. And I've seen some very, very wealthy people that they give testimonial dinners to and name schools after and everything. And nobody loves them, you know.
Hi guys, and welcome back. In this video we're going to learn how to test for errors that may happen in your functions. So what we're going to do is we're going to take our divide function. We're going to say if divisor is 0, we're going to raise a value error. We're going to say the divisor cannot be 0. Now what this means is if we pass in a divisor of 0, we need to have a test to see that value error is raised. So let's implement that test. This is also going to be helpful for you to learn how to check for errors in your tests in case you want to use that elsewhere. So I've created a test called test divide error on 0, and the syntax for checking an error, the easiest syntax is to say with self.assert raises and then type value error, or the type of error that this is going to raise, and in here you can write any code that should raise an error. In my case I'm going to do divide 25 by 0. Now, if the code in here does not raise an error, so if this test runs through this entire code, which at the moment is only one line, and there is no error raised, the test will fail. If there is an error raised, the test will pass. So let's run this. And you can see that we have 4 tests ran and the status is okay. This is how I recommend checking for an error, by using this context manager. However, you can also do self.assert raises, and in here you can put in the exception type and a callable. That means that you could do value error and then pass in here the callable. Notice that if we do 25 and 0 here, this is not a callable that we're passing. Here we're passing the result of calling the function, which is not the same thing. So you would have to type in a lambda of divide 25 by 0, or indeed any other function, but not call the function itself. So if you do this, this is the same thing. It works in exactly the same way, but I believe this is slightly worse in most circumstances. If you are testing a function that doesn't take any arguments, then you could do something like this. And then this syntax here may be better, or at least shorter. But because our divide function is taking arguments, then I find this a little bit more confusing. So I would go with the context manager instead by doing something like this. That's it for this video. This is how you check for errors being raised in your code, and I'll see you in the next one.
I think anyone who's in a field doing something that they truly love, it never feels like work.
Yeah.
And you feel a sense of liberation and freedom in doing that. You know, it could be any job, a corporate job, you're dancing, you're an athlete, anything, an actor, whatever it is.
Hi guys, and welcome back. In this video, we're going to be implementing a new function that we're going to call multiply, and we're going to be writing a few tests for it with what we know now on boundary value analysis and equivalence partitioning. Let's start by writing our function, which I'm going to call multiply, and what it's going to do is it's going to take any number of arguments, and each one is going to be either an int or a float. Notice that by doing star args, which by the way you can do star values or star a or whatever you want, by doing that, this function will be called like this, 359. You can pass in any number of arguments here. You don't have to pass in a list of arguments or anything like that. Just separate individual arguments to this function is what this star means in front of args. Okay, so now we've got that, and what we're going to do is check if the len of args is 0, and if it is, we're going to raise a value error, and we're going to say that at least one value to multiply must be passed, and do make sure to use the right brackets there. Otherwise, we're going to start at 1, and we're going to iterate over the arguments, and we're going to just multiply total by arg, and at the end we're going to return total. Very naive, very simple multiplication method, by far not the best one, but simple enough. However, if you look at this code, it may not be immediately obvious everything that it does and potentially all the different paths that code could take through it. So it is always good to write some tests when you have a function like this one, so that you can show people that look at the tests everything that you know about the function, and also so you can set in stone how you expect the function to behave. That way, if that changes later on down the line, some of your tests will fail and you'll be able to identify exactly what's changed in your code in case you didn't realize. So what we'll do is we'll start by testing a multiplication where the values or the arguments is empty. So we'll say test multiply empty, and then we will come here and say with self.assert raises a value error, we will just type multiply like that. And you do need to import it, of course. Now, if we run this, it should pass, because not passing any arguments will cause args to have a length of 0, and then this will raise a value error. At this point, I'm going to enable this toggle down on the bottom left so that this reruns every time I save the file. Let's go into our second test. Now that we've tested the empty arguments, we should also test boundaries around it, or rather the 0 argument is the boundary, so we should test 1 as well. So we're going to multiply a single value. So we'll say that the expected is 15, and we'll say self assert equal, multiply of expected should be the same value as expected. So whenever you multiply a single value, it should be the same. So now I'll press save. The tests will rerun down here, and you can see 6 of 6 pass. So this is good. Next up, we will try to multiply 0, because this could be a boundary, or rather it is a boundary that I've thought could potentially behave differently depending on the implementation of the function. So we'll say test multiply 0, and we will go for 0 here and type assert equal, multiply of expected should be expected. What this means is if you pass in 0 to the multiply function, it is still going to multiply whatever way it is using to multiply by 0, and that means you're always going to get 0 back. I can see how some incorrect implementations of a multiply function could potentially return 1 in this scenario. Not something you would expect, but it could happen. Next up, we are going to just test the multiply function does the correct thing. So we will go ahead and give the inputs, which are going to be 3 and 5 in my case, and the expected result, which is going to be 15. And then we'll say self.assert equal, the multiply with the inputs will be the expected value. Notice that I made a mistake here on purpose just to show you a couple of things. The first one is that I saved the file and the tests ran, and one of them fails, and you get here the error message. So you'll see that 15 is not equal to 3,5. So evidently the function returned 3,5 and not 15, which is what we were expecting. So that is because we didn't pass in the numbers. What we passed in is the tuple of the numbers. What we want to do is pass in 3 and 5 as separate arguments, like this. And in order to do that with inputs, you need to do star inputs. And that is going to pass exactly these values as individual arguments. Next up, we are going to include a 0 in our inputs. So we will say inputs are 3, 5, and 0, and the expected result is 0. So a very simple test, but nonetheless probably a necessary one. Just in case there is a check for 0 in the inputs or something like that. You can think that it's quite similar to the multiply 0, but in this case it is with more inputs here. We just want to make sure that our loop isn't, for example, ignoring 0 values, which I can see an implementation doing potentially if it was done incorrectly. Next up, we are going to multiply negative values, and we will expect the results to be minus 30 in this case. So there is another equivalence class there, minus 5, which you probably should test for. You can do things like test for double negative values, making sure it is a positive and so on, but that is probably getting too much into, does maths work in Python? So it's up to you how deep you want to go into this with these values, but I wouldn't put too many in there, just enough to check for, the boundaries themselves. Finally, we are going to multiply some floats, because that is another class here. So we'll do 3.0 and 2. Make sure that the output isn't floored or rounded or anything like that. So the expected is going to be 6.0, and we will do assert equal the multiply of inputs and the expected. So a couple more things you could do here. Of course, have different types of inputs like strings or tuples or lists and so on. Potentially, you may want to check the multiply function, make sure that these things are only ints and floats. You could have a type check inside the function, but those things are taken care of by the type hinting. So as long as the developer has type hinting enabled, when they try to call your multiply function with a string, for example, they should get a message saying, this function only takes ints and floats. So you don't have to test things that are already taken care of by the static analysis, in this case the type hinting. This is why type hinting is a pretty popular thing nowadays, and it's a very useful thing to have in your code base, and it's something that Python hasn't had for a long time, at least not official support for. So do make sure that you use type hinting, especially on functions because they can really help you and they can really prevent errors down the line. For example, if you define this multiply function in a specific way and somebody uses in a way that you don't expect, such as by passing a string or a tuple, you could get some errors in here that could easily be avoided just by showing the developer a nice message. So for now, that's our tests. If you can think of any more questions you'd like to ask your function and make sure that it does it over time as your code changes, do add those in here. If you're thinking that there's a lot of repetition in these tests, you would be correct. There is quite a lot of repetition in the inputs and outputs and self-assert equal. All of these tests do the same thing. So there are Python libraries to reduce this duplication, but they are not covered in this course. I'm sure that you can learn about them by looking at official documentations and things like that. For example, a library called Hypothesis comes to mind exactly to do that. That's it for this video though. Thanks for joining me. I'll see you on the next one.
So the biggest weakness right now is emotional dependency. That's the only reason why I'm not happy, because I have become emotionally dependent. Like physical dependency is illness, it's not health. Emotional dependency is illness, it is not health. Health is equal to happiness, healthier.
Hi guys and welcome back. Next up, we're going to be testing classes. So we're going to first of all create a new Python file. There's going to be our printer. And here we're going to create a printer class that has a simple init method with the pages per second and the capacity of the printer. And we're going to have a simple class here that just allows us to mock a print. So we've created this simple printer class, and what it does is it takes two values: how many pages this printer prints in 1 second, and how many pages it has capacity for, how much ink it's got left, if you will. Then there is a print method that prints a certain number of pages, unless the pages are above the current capacity, in which case it raises a printer error. After that, the capacity decreases by the number of pages printed, and it returns a nice message there that tells you how many pages were printed. We've also created a custom printer error class. That is what is raised here. Now let's go ahead and create a new file called testprinter.py. And here is where we're going to be writing our tests for this printer. Now, there's a couple of things that we need to look at when testing a class. The first thing is that we need to create a class object. So we need to think about whether we want to create that on every test or we want to create it once for the entire test case. We're going to look at how to do that and also at writing tests for this printer in the next video. So I'll see you there. Hi guys and welcome back. In this video we're going to be testing our printer class. Let's go over to the test printer and add our import, and then create our test printer case. Now let's write our first test. So we'll say test print within capacity, and we'll say that the printer is a new printer that has a certain number of pages per second, let's say 2 pages per second, and a capacity of 300. Okay. And I believe that this should be a float. Apologies for that. You do want a float there, just in case you can print like 2.5 pages per second. Now, we've got our printer object here, and we can say print 25 pages. Now, there are two things that you could do here. You could say that the test passes if the correct message is returned. Alternatively, you could say the test fails if an error is raised. So if you think the test should pass if there is no error, then this is a sufficient test, because if you run it, you'll see that no error is raised and therefore the test passes. All tests pass by default unless there is an error in them. Alternatively, you could say that the message is that, and then you could say self.assert equal message, or rather printed 25 pages in 12.5 seconds is equal to the message. Oh, that should be 12.50 seconds because we formatted it to 2 decimal places. And I have an error here. So you can see how writing this message out is actually potentially a helpful thing. There you have your test passing. Either of these is correct. I personally would not check for the message. I would have a separate test for that. I would just check that the printer prints. Now, for all our tests that we'll be writing, we will be using a printer object. So in order to reduce duplication, we can extract this and put it into a separate method that we'll call the setup method. And you don't need this return none, that is implied. So we'll say self.printer is a printer where the pages per second is 2.0 and the capacity is 300. And now what that means is you no longer need that, but you do need to use self.printer. Now this setup method here runs before each test. So if you have multiple test methods, this one will run before each one. So you always get a new printer every test. If you want to run this method only once for the entire test, then you will do setup class and you will get rid of this self here, and you could do cls.printer is this printer. And of course, you do need to make this a class method. And here you can still access self.printer and it will know that you refer to cls.printer just because of how Python's inheritance works. You would choose one or the other purely depending on whether you want a new printer every test or you want to reuse the same printer for the tests. Because the printer has a state that varies over time, and that is this capacity here, I strongly recommend that you do not share the printer across tests. So I would make this into a normal setup method like that. The reason for that is because if you write a test that uses up all of the capacity, say, then you have another test that tries to print some more, but you've run out of capacity, so the test would fail. If you have one printer for all tests, by having a printer for each test, you don't have that problem because you always get a new one for each test. So whenever you have state that changes in the object, create a new object for each test. Do not share objects across tests. Alright, I just wanted to show you about the setup and setup class. And also, I wanted to tell you that there is a tear down and tear down class. So that you've got tear down and tear down class, these two methods here, in case you want to run something after each test, that you can do, of course. That's everything for this video. Thanks for joining me in this one. I'll see you in the next one, where we're going to continue with some of this. I'll see you there.
You find happiness as you do your duty. You find happiness as you lead a disciplined life before God. You'll have periods of happiness. But God nowhere promises happiness is to be a goal in life.
Hi guys, and welcome back. In this video, we're going to be writing some more tests for the printer just to give you a bit more practice and show you a couple more things. Let's begin by writing a test for printing outside capacity. Like we did earlier, we will do with self.assert raises, and now it'll be a printer error that we're gonna catch. We'll do self.printer.print 301. Notice that we printed 25 pages in this test. So here we could in theory do 276 in order to still breach capacity. No, that's absolutely not correct. I hope that you didn't believe me there. You're getting a new printer for each test because we've got this setup and not setup class. Remember, exactly what I said there, this dependency between two tests is a bad thing. You do not want that. Okay? So you do need 301 pages in order to reach capacity, because this printer is a new printer related to this one. Okay? So this should raise a printer error. And indeed, as we save the file, these tests run and you get 2 out of 2. Notice that if we do 276, the test fails there, because the printer is a new printer. Okay? So it says printer error not raised. Hope you didn't believe me there. So next one is we are going to print the exact capacity. So we'll say test print the exact capacity. And we will do self.printer.print self.printer.capacity. Now this is a private property, or at least a property that has an underscore in front of it. So in theory you should not use it. But really what it means in Python is you should not change it. But you can still read it. And that's what we're reading here. So we're going to print exactly up to the capacity of the printer. And this is an important one to check, because it is very frequent that you will have something like this in your if statement. Is a fairly normal mistake to make, and then you'll see that it fails. And you will never be able to print the last page in your printer. Even when your printer has 1 page left of ink, if you have a check like this one, you won't be able to print it, because 1 will be equal to 1, which is the capacity left. So you want to do, if the pages is greater than the capacity, you want to raise the error. So if pages is 1 and capacity is 1, you will still print. If pages is 1 and capacity is 0, then you won't print and you'll raise an error. Okay, so this is an important one to check, very frequent mistake. Next up, we could test the printer speed, and this is really what we're doing here. So you could write a separate message that says test printer speed, and then you can have a pages 10 and an expected message of printed 10 pages in 5.00 seconds. Then you'll get your result, which will be self.printer.print 10 really pages. And then self.assert equal the result and the expected message. I would do this instead of checking the message here, and then I would remove this and put it there. That way you have 2 tests that do 2 separate things. If you get an error because you run out of capacity just by printing 25 pages, even though the capacity is 300, then you're going to catch it with this test and not with this one. Similarly, for example, let's say that you set capacity to 300, but you have hard-coded capacity to 20 here, and then your test will fail. This one. Self.printer.print 25 fails, even though you've set capacity to 300, because you hard-coded it to 20 here. This could happen, for example, if you forget to make it equal to capacity, and instead you hard-code it to a value while you're developing the class. That's why I'm a big fan of having separate tests that do separate individual checks, as opposed to one that does multiple things. Of course, sometimes you're not sure if your test is testing one thing or 2 things. It can be difficult to gauge, but don't worry too much about it. Just do the best you can, and I'm sure that over time you'll get better at it. Next up, let's test that the speed here, or how many seconds it takes, is always printed out to 2 decimal places and not, say, 10. So we will say that we've got a new printer called fast printer, that is another printer object, where the pages per second is 3.0 and the capacity is also 300. The pages we're going to print is 11, and the expected message is printed 11 pages in 3.67 seconds. This is important because the way that the Python will do it, if you divide 11 by 3.0, it'll be 3.66666667. And you don't want that normally when you're giving a message to a user. So we will say fastprinter.print pages, and then we will do self.assert equal the result and the expected. Okay, so run this and look at the tests pass, 5 out of 5. If you go back to your printer and you take away this 0.2f, you'll see that this test then fails. because you get, first of all, 5.0 seconds instead of 5.00, and then you also get 3.66665. I thought it would be 7, but it is not. Okay, so this is why we have that. And these tests here, really both of these are testing something similar, but this one is more gauged to testing, making sure the speed is correct. This one is making sure that the decimals are correct when there would be many of them. Next up, we can test for multiple print runs, making sure that a printer can print multiple times in succession. And we can print up to, say, the limit of capacity. Then we can test multiple runs end up in error, where we essentially do the same thing, but the last one is 226. Or maybe we can even make it a bit more explicit, just like that. Alright, so here are a few of the tests that we've come up with just for this simple printer class. And remember, the purpose of the tests is twofold, or mostly twofold. The first purpose is to document and to show the reader what the thing you're testing does and how it behaves in different scenarios. So by looking at these tests here, you need to take your time to, of course, understand them, but you'll be able to glean that this printer has a print method that returns a message and that erases an error. Here's how it behaves when you go over the limit, and you can print exactly up to the limit, and you can do multiple print runs and so on. So it's a little bit like documentation. And if you're working on a team and you're working with other people, there'll be a lot of code in a large code base that you've never seen before. By looking at the tests in the large code bases, you can much more easily understand everything that's going on, as long as the tests are good, of course. The second purpose of tests is to check that the code works in the same way that it did the last time. So if somebody comes into your printer and makes a few changes, for example, if they change this print method so that it no longer raises an error, you almost certainly want your tests to fail. Because if they don't, and then you can see that it tells me that to fail. If your tests don't fail, it means that potentially in many places in your code, you could be depending on that error being raised, and you are none the wiser. You don't know if that error is being raised or not anymore if you don't have tests for it. So the tests, the second purpose of the tests is to keep you right in what you believe about your code. Of course, there is a third and final use of tests, which is that by writing tests, it will force you to write better code. If the code is very difficult to test, you're going to have problems testing it. And that means usually that the code is too complicated. So you should split it out into functions and test those separately, and so on. In the coming videos, we're going to look at how you can split your code into functions and how to test when you have multiple layers. So we're going to be using patching and mocking in order to do that. It's really simple. It looks complicated, but it really isn't. Thanks for joining me in this video. I'll see you in the next one.
I believe in the power of wandering. All of my best decisions in business and in life have been made with heart, intuition, guts, not analysis. When you can make a decision with analysis, you should do so, but it turns out in life that your most important decisions are always made with instinct, intuition, taste, heart.
Hi guys, and welcome back. In this video, we're going to be learning about patching and mocking. Let's start by creating a new file that we're going to call page.py. And here we're going to import the requests module. So if you don't have it installed, just go over to your settings, open your project interpreter settings, and install the requests module. This module here just allows us to get a web page and look at its contents, basically. So it allows us to make web requests. Now that that's installed, we can go to OK, and this should disappear there, the red line. And then we're going to create a class that I'm going to call page requester, and it's going to be a very useless class. but nonetheless it's going to allow us to learn about testing. So we're going to get the page requester class, and it has an init method. This one receives a string, a URL. We can say that this is a string there. And then it has a get method that all it does is it calls the requests module. And it gives you back the content of the response. Now, you may think that this is a useless example, but very often what you'll see is that your classes get very long. And as your classes get longer and longer, understanding them becomes naturally more difficult. There is more code to read, you have to be jumping from one place to another, and so on. So it's often a good idea to split out the code in your classes, take it out, put it inside another file, create a function for it, or potentially another class if it's necessary, and test that separately from this class. This class now, where we've taken all of the code that actually goes and gets the URL and so forth, we've taken all that into a new file, the requests module. Now this class is very simple. All we have to do is make sure that the URL is stored in the class and that the get method calls the requests module. So we can go ahead and write our tests for it. Let's create a new file that I'm going to call testpage.py. And once again, we will begin by doing from unit test, import test case. We will do from unit test.mock, import patch, and from page, import page requester. Then we'll create our test page requester, which is a test case. And we're going to set up the method here to do self.page is page requester, and we will pass in google.com. Just a simple page there. Now, what we want to do is we want to make sure that when we call self.page.get, it calls the requests module. We do not want to have a test that actually gets google.com. Here's why. So we'll say test make request, and we're going to do with patch of requests.get as mocked get. And what this does is it goes into the requests module, looks at, or rather, it goes into the requests import, which is what we've imported here. And if we use requests.get anywhere in our application, it's going to be replaced by whatever this patch function returns. So it's going to get replaced by a mock. And I'll show you what a mock is in just a moment. So what we want to do once we've patched requests.get is we want to say self.page.get. And then mockedget.assert called. All right, so now let's get into why we're doing this. When we write the requests module, so whoever wrote the requests module, he wrote tests for the requests module. You don't have to use the requests code and make sure that it works. If we write this test without patching requests.get, really we're testing two things. The first thing we're doing is we are testing that our function calls the requests module, because that's really what it does. But the second thing is we're testing that the requests module also works because we're actually interacting with the requests module. If you patch it, you are never interacting with the requests module. All you're doing is you're interacting with this mock that we're creating. That means that there is a separation between the requests module code that we are not testing and our code that we are testing. And on the line between those two is this mock. By checking that we are calling the requests module, that is everything we need to check, because the requests module is tested separately and we don't have to test it ourselves. Now, there is a thing that our function does, that our method does, that isn't tested by that one, and is that it gets the content of the response. So we do have to write a test for this specific thing. Make sure that whatever we get back, we are accessing the content property of that. This mock here that we've used does not have a content property. And I will show you exactly how I know that. going to type response is that, and we'll see print response. Now we're going to run this test here. So we'll right click it and press run these tests. And you see that what you get back when you do this patch is something called a magic mock. This is part of the Python unit test module. Whenever you access anything inside the magic mock, it will allow you to access it. So for example, you can say print response dot Rolf. Let's run this again. And notice that it is totally okay with it. And what you get back is another magic mock. When you do magic mock dot anything, the magic mock automatically creates the property and gives it the value of another magic mock. So really, with this test here, we're not testing that we get a valid content thing from our response. We are not checking that this stuff here is working. We're just checking that we are getting something from the requests module. If you want to patch this and make it return something that has a content property so that you can then make sure that you are getting the content property back, you have to do that separately without using the magic mock. So let's write a test for content returned. And here we need to define an inner class that is going to be a fake response. So we're going to say requests module. When I call the get method, instead of returning the real response from google.com, give me this fake response. So we will define the init method here, and we will say self.content is hello. And this is a fake response that we've used in here. And now we'll say with patch requests.get, and the return value is going to be a fake response. And what this does is when you do requests.get like this, you're going to get back a fake response object that we've created just now. That means that when you do result equals self.page.get, what's happening is self.page.get is calling requests.get, and this stuff here will be your fake response object. And then you're accessing the content property of your fake response. So you can do self assert equal result should be hello. And we can do fake content is hello and put it in here. All right. Now this will pass as well if we run it. And we have successfully faked what the method here is going to return. This is a very common pattern where you fake the return value of something. We've learned how to fake the return value of a function and also how to make sure that it was called. There's a lot more on patching and mocking in the official documentation that I have linked in the resources section of this lecture. So please do give it a read if you want to do more on this. There is a lot to know, and it can get a little bit confusing when you start to play with different, side effects and other things that these mocks can do, and when you start using mocks instead of magic mocks, and so on. So if you want to do more testing, I would recommend looking at that and potentially also going deeper into learning about unit testing in Python. There is quite a lot to do. Thanks for joining me in this video. I'll see you on the next one.